welcome to our video on unsaturated hydrocarbons, specifically alkynes. Alkynes are a class of unsaturated hydrocarbons that contain at least one carbon-carbon triple bond. They are also known as acetylenes and are characterized by their unsaturated nature and high reactivity. In this video, we will explore the nomenclature of alkynes, sp hybridization and the formation of ethyne molecule and IUPAC naming of structural formulas of some alkynes. So, if you are interested in learning more about the fascinating world of alkynes, then keep watching. Now let us see what are alkynes. Alkynes are unsaturated hydrocarbons containing at least one carbon-carbon triple bond. The number of carbon atoms is still less in alkynes as compared to alkenes. Alkynes contain 4 hydrogen atoms less than the corresponding alkanes. Alkynes form a homologous series having the general formula CnH2n-2. So the general formula of alkynes is CnH2n-2, where N represents the number of carbon atoms. The first and the most important member of this series is acetylene. HC triple bond CH. Hence, alkynes are also called acetylenes. Now let us talk about the nomenclature of alkynes. There are 3 systems for naming alkynes. The first one is the common name system. The common names of alkynes do not bear any relationship and are based on the names of related compounds. Here are some alkynes and their common names. The first member of alkynes series is C2H2 and its condensed formula is HC triple bond CH. The common name of this alkyne is acetylene. The next member of the alkynes series is C3H4. When N is equal to 3, we get C3H4 and its condensed formula has been given in the bracket, and the common name of this molecule is aniline. The next member is C4H6 and here is the condensed formula. The common name of this alkyne is crotonylene. Here you can see alkynes form homologous series. Okay, that means each member of the series differs from the previous member by a CH2 unit. If you compare the molecular formulas of these 2 alkynes, there is CH2 difference. Okay, so in this molecule, 1 carbon and 2 hydrogen atoms are more than this molecule. Okay, so alkynes form homologous series. And except acetylene, other common names are no longer used. The second system of naming alkynes is derived system. In this system, the higher alkynes are regarded as alkyl derivatives of acetylene. Here are some alkynes and their derived names. We know the first member of alkynes series is C2H2 and its derived name is acetylene only. Here CH3C triple bond CH. This one is one of the higher alkynes. So in this CH3 group is there, for that reason it is methyl acetylene. And in this CH3 CH2 group is there, so this is ethyl group, so it is called ethyl acetylene. In this alkyne there are two methyl groups, so it is dimethyl acetylene. Okay, so like this, higher alkynes are named as alkyl derivatives of acetylene. The third system of naming alkynes is IUPAC system. IUPAC names are obtained by dropping ANE of the parent alkane and adding the suffix YNE. That means alkane minus ANE plus YNE, we get alkyne. That means we have to remove ANE and add YNE to it, so that we get alkyne, alk plus ine, alkyne. Here are some alkynes and their IUPAC names. We know the first member of alkynes series is C2H2 and its common name is acetylene. The IUPAC name of the first member of the alkynes series is ethyne, eth plus ine, ethyne. The next one is C3H4 propyne, and this one, the IUPAC name of this alkyne is but1-ine, and IUPAC name of this one is but2-ine. So here, depending upon the position of the triple bond in the carbon chain, IUPAC names are given to alkynes. So when the triple bond can take up more than one position in the molecule, the carbon chain is numbered in such a way as to give minimum numbered carbon atom bearing triple bond. So more about IUPAC names of alkynes will be discussed later. Now let us see the formation of ethyne, that is acetylene molecule. The formation of ethyne molecule involves sp hybridization. Let us explore further about sp hybridization and the formation of ethyne molecule. The molecular formula of ethyne or acetylene is C2H2. We know the atomic number of carbon is 6. Its electronic configuration in the ground state is 1s2, 2s2, 2p2. That means 1s orbital contains 2 electrons. 2s orbital also contains 2 electrons. And there are 3 equi-energy 2p orbitals, say 2px, 2py and 2pz. 2px and 2py orbitals contains 1 electron in each. So this is the ground state electronic configuration of carbon atom. The electronic configuration of carbon atom in the excited state is 1s2, 2s1, 2p3. That means in the excited state, carbon atom promotes 1 electron from 2s orbital to the empty 2pz orbital. Okay. So this is the ground state electronic configuration, but in the excited state, one of the electrons in 2s orbital jumps and occupy the empty 2pz orbital. Then 4 unpaired electrons are available in the outermost orbit of carbon atom. So this is the excited state electronic configuration of carbon atom. Here you can see the outermost electronic configuration of carbon atom in the excited state. It is 2s1 2p3. So I will arrange these orbitals according to their energy level. So here the 2s, the energy of 2s orbital is less than the energy of these three 2p orbitals. Okay, so in the formation of C2H2, each carbon atom in its excited state undergoes sp hybridization by intermixing of one s orbital and one p orbital and reshuffling to form two sp hybrid orbitals. So in sp hybridization, one s orbital, that is 2s orbital, and one of the p orbitals, say 2px orbital, intermix, that is combine, and gives two equal energy orbitals, that is two sp hybrid orbitals. So these two orbitals intermix and form two sp hybrid orbitals. Okay, and each sp hybrid orbital contains one electron. So sp hybridization occurs when one s orbital and one p orbital mix together to form two equivalent hybrid orbitals lie in a straight line. You can better understand the sp hybridization by visualizing atomic orbitals. See here, this is the nucleus of carbon atom, and around this nucleus I am going to show you only the outermost orbitals of carbon atom. So this is one of the p orbitals, say 2px. Here is another p orbital, say 2py, and the third p orbital 2pz, and this one is the 2s orbital. So here I have shown only the outermost orbitals of carbon atom. Each orbital contains an unpaired electron. All these four orbitals are unhybridized orbitals only. That is, before sp hybridization, this is the situation of carbon atom. In sp hybridization, what happens? One s orbital, that is 2s orbital, intermix one of the p orbitals, say 2px orbital. These two orbitals will intermix and form two new sp hybrid orbitals. Okay, so two sp hybrid orbitals lie in a straight line, that is, the angle between them is 180 degrees. Okay, and the other two 2p orbitals, say 2py and 2pz, are left unhybridized. These are the unhybridized orbitals around the carbon atom. Okay, so the unhybridized orbitals, that is 2py and 2pz, are at right angles to the line of sp hybrid orbitals. So after hybridization, each sp orbital and unhybridized p orbital contain an unpaired electron. See here, here is one unpaired electron, here is one, here is one, here is one. So this is the sp hybridization. Okay, Now we can see the bonds formation after sp hybridization. One sp hybrid orbital of a carbon atom overlaps coaxially with that of another sp hybrid orbital of another carbon atom to form a sigma bond. So this is one carbon atom. After carbon atom undergoes sp hybridization, the orbitals look like this. So in this, there are two sp hybrid orbitals containing an unpaired electron in each and two 2p unhybrid orbitals containing an unpaired electron. So totally 4 unpaired electrons are available around the carbon atom now. And this one is the another carbon atom. So the sp orbital of this carbon atom will overlap with the sp orbital of this carbon atom. End on end overlapping will take place now, and resulting the formation of one sigma bond. See here, these two are overlapping. Okay, so due to the end to end overlapping, here we are getting one sigma bond, sigma sp sp overlapping. Okay, the remaining sp hybrid orbitals of two carbon atoms overlap with 1s orbital of two different hydrogen atoms to form two sigma bonds. You know, in hydrogen there is only one electron, and that electron is there in 1s orbital. So this is the 1s orbital of hydrogen atom, and 1s orbital of hydrogen atom contains an unpaired electron, and these two will overlap to form one sigma bond. Hydrogen atom, these two are overlapping and forms one sigma bond, sigma sps. And here is another hydrogen atom, and it overlaps with this sp hybrid orbital and forms sigma bond, sigma sps. Okay, so these are the sigma bonds formed between two carbon atoms and between two hydrogen atoms with two sp hybrid orbitals. The unhybridized p orbitals of two carbon atoms overlap laterally to form two pi bonds. Now, these two 2py orbitals overlap laterally, resulting to form pi bond. See here, these two 2py orbitals are going to overlap laterally like this and forms one pi bond between the two carbon atoms. So pi py py, and these two 2pz unhybridized orbitals will overlap sideways, that is laterally, to form one more pi bond between the two carbon atoms like this. Okay, so like this C2H2 molecule will be formed, pi pz pz. So the triple bond between two carbon atoms, that is C triple bond C, consists of one sigma bond and two pi bonds. Sigma bond has been formed due to the end-on-end overlapping of two sp hybrid orbitals, and the two pi bonds have been formed due to the sideways overlapping of 2py and 2pz orbitals respectively. Okay. Now let us explore the nomenclature of alkynes IUPAC system. The name is obtained by dropping the suffix ane from the name of the corresponding alkane and adding the suffix yne. That means alkane minus ane plus yne, we get alkyne. That means we have to remove ane from alkane and add yne to it so that we get alkyne. The longest chain of carbon atoms containing the triple bond is selected. Numbering of the chain is done from the end which is nearer to the triple bond. When there are 2 or 3 triple bonds in the molecule, the ending ane of the corresponding alkane is replaced by adiene, atriene, adiene, atriene. That is alkadiene, alkatriene, like this. The first stable member of alkyne series is C2H2 known as acetylene. Acetylene is the common name and its IUPAC name is ethyne. Okay. Now let us see IUPAC names of a few members of alkynes. That means we will be given some alkynes structures. We have to write their IUPAC names according to the rules we have studied so far. Write the IUPAC name of the following structure. Here is the structure: CH3 bond CH2 bond C triple bond CH. Here is the answer for this. How to write the IUPAC name for this structure? The number that locates the position of the substituent, that is triple bond, is known as locant. That means here I am considering the triple bond as the substituent here. So it is called as the locant. Okay. Lowest locant rule we have to apply. The carbon atoms carrying the first substituent, that is triple bond, get the lowest possible number. That means we have to give the numbering either from left to right or from right to left, isn't it? But numbering of the chain is to be done from the end which is nearer to the triple bond only. So suppose if I give the numbering from left to right, third carbon atom contains triple bond. If I give the numbering from right to left, first carbon atom is containing the triple bond. So this one is the wrong numbering, this one is the correct numbering. Okay, so we have to give the number in such a way that the triple bond, that means the carbon atom containing the triple bond should be given the least possible number. Okay. Now, what is the root word? How many carbon atoms are there in this chain? There are 4 carbon atoms. That means it is, the root word is but. Next, primary suffix. So in primary suffixes, depending upon the nature of saturation, primary suffix is defined. Here carbon-carbon triple bond is there in our chain here in this carbon chain. So it is YN, ine, YN. Next, secondary suffix. In this carbon chain only hydrocarbons are there, no other atoms are present. So the functional group or otherwise secondary suffix for CH, that is hydrocarbons, is E. If only hydrocarbons are there other than any functional groups, and the secondary suffix for that is E. Okay. So the IUPAC name is but1-ine. That means the first carbon is bearing the triple bond, but1-ine. Write the IUPAC name of the following structure. Second one, see here, CH3 bond C triple bond C bond CH2. Here is the answer, CH3 bond C triple bond C bond CH2. So we can give the numbering either from left to right or from right to left. We get the same here in this case. Suppose that means if you give the numbering from left to right, the second carbon is containing the triple bond. If we give the numbering from right to left, again second carbon only contains the triple bond. So the root word is 4 carbon atoms are there, it is but, and primary suffix triple bond is there, it is yn. Secondary suffix only hydrocarbons are there, it is E. So the name of this structure is but-2-ine. But-2-ine. Okay. And let us see one more structure. Write the IUPAC name of the following structure. CH3 bond CH2 bond CH2 bond C triple bond CH. Okay. So this is the given structure and we have to do the numbering. First I am giving the numbering from left to right. If I give the numbering from left to right, the fourth carbon is bearing the triple bond. If I give the numbering from right to left, first carbon is bearing the triple bond. So this one is the wrong numbering, this one is the correct numbering, and the root word, the chain contains 5 carbon atoms. So what is the root word? When 5 carbon atoms are there, it is pent. Okay. Next, primary suffix, triple bond is there, it is yn, and secondary suffix is only E because only hydrocarbons are present in this. Okay. So the IUPAC name of this structure is pent-1-ine. The next one is write the IUPAC name of the following structure. CH2 triple bond C bond C triple bond CH, and in this structure there are 2 triple bonds. When more than one triple bond is there in the given structure, we have to follow the lowest sum rule. What is that? When many substituents, that is triple bonds, are present, the numbering is done from the end whereupon the sum of locants is the lowest. So in this case, numbering can be given either from left to right or from right to left. But the only condition is there that we have to do the numbering from the end in such a way that sum of the locants should be least. So here I am doing numbering from left to right. So here the locants are, just now we have seen what is the meaning of locant. The carbon atom containing the triple bond, the number of the carbon atom containing the triple bond is called locant. Here 1 and 3 are the locants. That is, the first carbon and the third carbon are containing the triple bonds. Okay, so 1, 3 are the locants in this case. Suppose if numbering is given from right to left, first carbon and third carbon are containing the triple bonds. So left to right, sum of locants is 1 plus 3 is equal to 4. Right to left, sum of locants 1 plus 3 is equal to 4. So in this case, numbering can be done in either way because both ways are correct. So root word is here when more than one triple bond is there, that is in this case there are 2 triple bonds. When there are two triple bonds in the molecule, the IUPAC name is alk plus adine. Alk plus adine. Okay, alkadiene. So here, not but here, we have to add a to this. It is buta. Next, primary suffix triple bond is there. It is yn. Secondary suffix, only hydrocarbons are there. Hydrogen and carbons are there in this. For that reason, it is secondary suffix is only e. And the name of this structure IUPAC name is buta 1, 3 diene. Buta 1, 3 diene. Next one, fifth one, write the IUPAC name of the following structure. This is the structure. In this structure also, okay, two triple bonds are there. So we have to give the numbering in such a way that some of the locants should be least. First, let us write the given structure as it is. Okay, so here I am giving the numbering from left to right and right to left. So let us ascertain which one is correct. Left to right, sum of locants. So if we consider the numbering from left to right, second carbon and the fourth carbon are containing the triple bonds. So sum of locants is equal to 2 plus 4 is equal to 6. From right to left, if we consider the numbering from right to left, it is third carbon and the fifth carbon are carrying triple bonds. So sum of the locants is least in the case of left to right numbering. So this one is the wrong numbering, this one the correct numbering. Then root word, how many carbon atoms are there in this? 1, 2, 3, 4, 5, 6, 7 carbon atoms are there. It is when there are two triple bonds in the molecule, the IUPAC name just now we have seen alk plus adine. Alkadiene. So here it is hepta. Okay. Then primary suffix is triple bond is there yn and secondary suffix e. Okay. So the name of this structure we can write here IUPAC name hepta 2 that is on the second carbon, 4 that is on the fourth carbon, triple bond is there. So hepta 2,4 diene. Hepta 2, 4 diene. Next, the sixth problem, write the IUPAC name of the following structure. So this is the given structure. We have to write the IUPAC name for this. Okay. Lowest sum rule. When many substituents, that is triple bonds, are present, the numbering is done from the end whereupon the sum of locants is the lowest. Same rule we have to follow here. And in the given structure, 3 triple bonds are there. Okay. And we have to give the carbon atoms we have to give the numbering to the carbon atoms containing the triple bond in such a way that the sum of locants should be least. So let us check. This is the given structure. Now I am giving the numbering from left to right. Okay. Now you can see the locants here, that is number of the carbon atoms containing the triple bonds. First carbon atom, fourth carbon atom and sixth carbon atom. So 1, 4 and 6, these are the locants. Next, if I give the numbering from right to left, second, fourth, seventh, these are the locants. Now let us sum up the locants from left to right. 1 plus 4 plus 6 is equal to 11. From right to left, 2 plus 4 plus 7, we get 13. So left to right, numbering from left to right is the correct numbering, because sum of locants is least in this case. Wrong numbering, correct numbering. Root word. In this 8 carbon atoms are there, it is, just now we have seen, when there are 3 triple bonds in the molecule, the IUPAC name is alk plus ethyne, that is alkyne. So it is octa, primary suffix is yn, because triple bonds are there, it is yn, because nature of saturation is triple bond here. Secondary suffix, this structure contains only hydrogen and carbon atoms. For that reason, for hydrocarbons, the functional group is E. Secondary suffix is E. Okay. So IUPAC name is octa. Okay. 1, 4, 6 triene. Octa 1, 4, 6 triene. The next one is write the IUPAC name of the following structure. Here is a structure, alkyne structure. We have to write the IUPAC name for it. So this also contains 3 triple bonds. So again we have to use the same rule, that is lowest sum rule. When many substituents, that is triple bonds, are present, the numbering is done from the end whereupon the sum of locants is the lowest. So we can give the numbering to the carbon atoms in the chain either from left to right or from right to left, but we have to see the sum of locants should be least. So here numbering is being done from left to right. The locants are 2, 4, 6. If numbering is done from right to left, 2, 4, 6. So left to right, the sum of locants is 12. Right to left also, 2 plus 4 plus 6 is equal to 12. So second carbon, fourth carbon, sixth carbon, these are containing triple bonds from left to right. From right to left also, second carbon, fourth carbon and sixth carbon. So numbering can be done in either ways because both are correct. So root word is, in this, when there are 3 triple bonds in the molecule, the IUPAC name is alk plus ethyne, alkyne. So here we should not use oct simply. Instead we have to add a to this, alky, octa. Okay. Next, primary suffix is, because triple bonds are there in this, it is yn. And secondary suffix is, in this carbon chain only carbon and hydrogen atoms are there. So it is only hydrocarbon. For hydrocarbons, the secondary suffix is E. Then the IUPAC name is octa 246 triene. Octa 246 triene. Okay. Thank you.